Good morning, dear students. A warm welcome to all of you for our today's digital session for the subject Science and Technology Section A. Yesterday, we have revised chapter number 6 from Section A, Refraction of Light, and also a part of chapter number 2, Periodic Classification of Elements. In today's session, we will continue with the revision for chapter number 2, Periodic Classification of Elements, and if time permits, we will start with the revision for chapter number 3, Chemical Reactions and Equations. So let us first proceed towards the revision of chapter number 2. In periodic classification of elements, yesterday we have revised about Doberiner's law of triads and Newland's law of octaves. Also, we had seen their limitations. After the law of Doberiner and Newland, the next scientist to come ahead with his discovery was Dmitry Mendeleev. He was a Russian scientist and he developed the periodic table of elements during the period 1869 to 1872 AD. Now, his discovery, his periodic table, it was considered as a very important step in the classification of elements. Why? Because he was the first scientist who successfully classified all the known 63 elements at that time. He had arranged the elements in an increasing order of their atomic masses. Means what? Here also atomic mass was considered as the fundamental property as done by Doberiner and Newland. This scientist, he transformed this into the periodic table of elements and in accordance with the physical and chemical properties of these elements. And what he found that after he organized the periodic table, he had organized on the basis of chemical and physical properties, and what was his inference that elements with similar chemical and physical properties, they showed repetitions. They repeated after a definite interval, and on the basis of this finding, he formulated his periodic table and put forth his periodic law, which states that properties of elements are periodic function of their atomic masses. Also, the vertical columns in Mendeleev's periodic table, they were called as groups, while the horizontal rows are called as periods. It can be asked as a fill-up or true and false in the exam. Now let us proceed towards the merits and demerits of his periodic table. Yes, we can say that he was a successful scientist, but as you know, every coin has two sides. Along with merits, his periodic table also has certain demerits. First, we will see the good side of the coin, that is the merits. Now, as we all know that science is progressive, science progresses on its own and there is a freedom in science to revise the old inference by using more advanced means and methods of doing experiments, and these characteristics of science, they are clearly seen in the Mendeleev's periodic table. While applying his law that the properties of elements are a periodic function of atomic masses to all the known elements at that time, what he did, he arranged the elements with a thought that the information available till then was not final, but it can change ahead. And this is a very important step, this is a very important thought. And based on this thought, his first change, which was accepted as a merit, was that atomic masses of some elements were revised by him so as to give them proper place in the periodic table in accordance with their properties. Here one example, if you see the atomic mass of beryllium, which was 14.09 previously. It was changed to the correct value 9.4, and hence beryllium, on this discovery, it was given a place before boron. His next very important merit is, before the elements could be discovered, he had kept some vacant places, some blank places in his periodic table. These three unknown elements, they were also given the names Ica boron, Ica aluminium and Ica silicon. Here we had taken a good example. If the class is occupied by students, if suppose 60 students are there at presently in the class, if the teacher just predicts that 3 more children are going to be added this year, not only the prediction of the teacher, but also if the teacher has left some places in the catalog, the places to sit for the children, and later on when the children are admitted in the school, if their names and all match with the blank places in the catalog, then we can surely say that it is a great advantage, a great prediction by the teacher. See, the same applies here. He had left the vacant places, he had given their names. Not only this, but their properties were also predicted. Then later on, when these elements were discovered, they were named as scandium, gallium and germanium respectively. Here the main magic lies is that the properties of these elements which were discovered later on, they matched well with those which were predicted by Mendeleev, and due to this success, all in the world were convinced about the importance of Mendeleev's periodic table, and this method of classification of elements, it was accepted immediately. Third and the last merit is, there was no place reserved for the noble gases. You all know which are the noble gases. The inert gases which are stable, which do not participate in any of the chemical reactions. They are known as noble gases. So there was no place reserved for noble gases in Mendeleev's original periodic table. But later on, when noble gases such as helium, neon, argon, they were discovered, he created, this Mendeleev, this scientist, he created the zero group without disturbing the original periodic table, in which the noble gases were fitted very well. There was no chaos, there was no confusion as to where to place this noble gases. So immediately he created the zero group, and the other periodic table, it remained untouched, it remained unchanged. Now let us see the demerits. Now the first demerit was the biggest problem with the case of cobalt and nickel. The whole number atomic mass of both these elements, cobalt which is 58.93 and nickel which is 58.71, is the same, and hence there was a big question ahead of Mendeleev regarding the sequence in his periodic table. Next was the problem with isotopes, no proper placing of isotopes of elements. Now isotopes, this were discovered long time after Mendeleev put forth the periodic table, and you all know that isotopes, they have the same chemical properties but different atomic masses. They are the atoms of the same elements having different atomic masses, and hence a challenge was posed ahead of Mendeleev as to where to place them in his periodic table. Next is, when the elements are arranged in an increasing order of atomic masses, you know the main fundamental property here. Mendeleev's periodic table was also based on atomic masses. So when the elements were arranged in an increasing order of atomic masses, the rise in the atomic mass does not appear to be stable, does not appear to be uniform. It was not possible therefore to predict how many elements could be discovered between any two of the heavy elements. And last but not the least is regarding the position of hydrogen, because Hydrogen, it resembled properties with both halogens and also the alkali metals, that is group 1. So there is a similarity in the molecular formulae with the of this hydrogen. There is a similarity in the molecular formula of the compounds of hydrogen alkali metals, that is with sodium, potassium, etc., formed with chlorine and oxygen. On considering the above properties, it cannot be decided whether the correct position of hydrogen, it should be placed in group 1, that is alkali metals, or it should be placed in a group of halogens, because valency is 1 and you know valency of halogens is also 1. So there was a big position, you can say confusion ahead of Mendeleev to give a position to hydrogen, and as you know hydrogen is the first element having the atomic number 1. So these are the merits and demerits of Mendeleev's periodic table. Study them thoroughly for the board exams. In March 2020, demerits were asked. So both the concepts should be clear with you. After some of the limitations which were found in Mendeleev's periodic table under the heading of demerits, the next scientist to come ahead with his discovery was Henry Moseley in the year 1913 AD. This English scientist Henry Moseley, he demonstrated with the help of experiments which are done by him using X-ray tube, he told the world, he demonstrated that the atomic number of an element, it corresponds to the positive charge on the nucleus or the number of protons in the nucleus of the atom of that particular element. And thus what he revealed, what he inferred was that atomic number is a more fundamental property. You can see the picture of Henry Moseley. He inferred that atomic number is the more fundamental property of an element rather than its atomic mass. And this discovery was a challengeful step. It was, you can say, a successful step in the, you can say, field of classification of elements, and based on his discovery he formulated his law stating properties of the elements are a periodic function of their atomic numbers. See the basic difference between the other laws and modern periodic law. Just now I have told Mendeleev's periodic law, it is similar to modern periodic law, only in place of atomic numbers it is atomic masses. Now let us just go through the structure of the modern periodic table which was formed by Henry Moseley, and let us see what groups, what periods are included, whether they are little bit match with Mendeleev's periodic table. Now the arrangement of the elements in an increasing order of their atomic numbers is the basis of modern periodic table. You can see the elements are arranged in the increasing order of their atomic numbers. The first starts with hydrogen having atomic number 1, then helium 2, lithium 3, beryllium 4 and so on. This modern periodic table, it is also called as the long form of the periodic table. Now this modern periodic table, it has 7 horizontal rows. 1, 2, 3, 4 horizontal rows. You can see 1, 2, 3, 4, 5, 6, 7 horizontal rows are there, and also these horizontal rows were called as periods and numbered from 1 to 7. The 18 vertical columns, these are the vertical columns from 1 to 18. The 18 vertical columns are called as groups and they are numbered from 1 to 18. Atomic numbers, if you see, are serially indicated in the upper part of the boxes. You can see atomic number 1, atomic number 2. In the upper part of the boxes, the atomic numbers are mentioned. Each box corresponds to the place for one element. Which box? The arrangement of the periods and the groups, they result in the formation of boxes. You can see these boxes, and in each box you can see one element. So each box corresponds to the place for one element, and apart from this 7 rows, 2 rows are shown separately at the bottom of the periodic table. They are known as the lanthanide and the actinide series respectively. So total if you count, there are 118 boxes. You can see up till here. Starts from 1 up to 118. There are total 118 boxes in the modern periodic table, including both the series which are there at the bottom. So what does it mean? There are 118 places for elements in the modern periodic table. The entire periodic table, if you see, is divided into 4 blocks: S block, P block, D block, and last 2 at the bottom, they are called as F block. Now S block, if you see, it contains group 1 and 2. So elements from group 1 and 2 are placed in the S block. The groups 13 to 18. The groups 13 to 18, they constitute or form the P block. Groups 3 to 12 in the middle of the periodic table, they constitute the D block, while the lanthanide and the actinide series present at the bottom of the periodic table, they form the F block. Now, a big characteristic of the P block is that this is the only block which contains all metals, non-metals and metalloids. You can see this zigzag line, and along this zigzag line your the metalloids are formed to be lying. What are metalloids? They are the elements which show the property of both metals as well as non-metals. So all the metals, they lie on the left hand side of the zigzag line, and the non-metals, they lie on the right hand side of your zigzag line. So this is about the modern periodic table. Let us go through the points once again. The first is 7 horizontal rows called as periods. The second structure says 18 vertical columns called as groups. 2 separate rows, lanthanide and actinide series at the bottom of the periodic table. 118 boxes are reserved each for 118 elements. The entire modern periodic table is divided into 4 blocks: S block, P block, D block and F block. Metals lie on the left hand side of the zigzag line and non-metals on the right hand side, and along the zigzag line you will find the metalloid elements. They lie along the border of the zigzag line. Now next we are going to study about the modern periodic table and the electronic configuration of elements. Now if you see within a period, the neighboring elements, they differ slightly in their properties, while the distant elements, they differ widely in their properties. This is for the elements which are formed within a period, which are found within a particular period. Now, elements in the same group, all the elements which are present in the same group, they show similarity and gradation in their properties. Now, this characteristics of the groups and the periods in the modern periodic table, it is a result of what? They are because of the electronic configuration of elements. And for a group, as I have told you, elements which are present, they show similarity and gradation. And you all know about valency. All the elements belonging to the same group, they show the same valency. It is because all the elements belonging to the same group, they have the same number of valence electrons. Now, taking this topic in mind, keeping this concept of electronic configuration, we'll move towards our next topic, that is groups and electronic configuration. Groups and electronic configuration of elements. I have taught you last year in the 9th standard how and what is electronic configuration. Configuration means placement. Placement of electrons around the nucleus in proper orbits is called as electronic configuration. Now, while going from top to bottom within any group, one electronic shell gets added at a time. Means if you take the first group, there is only one shell. If you move to the second group, then elements from the top to bottom, when you see the first element, it will have only one shell. Second element below it, it will have two shells, and so on. Means one shell is getting added at a time, and thus the electronic configuration of the outermost shell is the characteristic of any group. As we go down a group, as one shell gets added at a time, the number of shells goes on increasing. So group number, it indicates the valence electrons in the outermost shell. Just now I have told you, group 1, elements belonging to group 1, they will show valency 1 because they have one valence electron in its outermost shell. So hydrogen is belonging to group 1, one valence electron. Aluminium to group 3, so 3 valence electrons. So the group number indicates the valence electrons in the outermost shell. And as a result of this, all the elements belonging to the same group have the same number of valence electrons, hence have the same valency. It is a very important new reason. It was asked in one of the board exams. Elements belonging to the same group have the same valency. So when you are writing the answer for this part, the first thing you are going to say that what is valency. After that you will say all the elements belonging to the same group, they have the same number of valence electrons, hence they have the same valency, and then this statement we are going to support with examples. You can take any group and 2-3 examples from that group, and you can see, you can express over there that all the elements belonging to that particular group, they have the same valency. Our next topic is periods and electronic configuration. Just now we have seen about groups. Now we will study about periods and electronic configuration. So while going from left to right within a period, the atomic number increases by 1 at a time, and hence what will happen? The number of valence electrons also increases by 1 at a time, and elements with the same number of shells occupied by electrons, they belong to the same period. Now in the modern periodic table, if you see, electrons are filled in the same shell while going along a period from left to right, and at the beginning of the next period, that is when you go from the first to the second period, a new electron shell starts filling up. Just we will go behind to the periodic table so you will understand. You can see this is the first block, S block. So first group, second group, third group. This is your first period, second period. So in the first period, hydrogen, it has only one shell because one electron is there. When you go to the next element of the second period, there you will see lithium, atomic number is 3. So to accommodate the 3 electrons, 2 shells will be required. If you go to the first element of the third period, that is your next period, sodium has 3 shells. Means just now I have told you that when you go from left to right within a period, what happens with the case of atomic number? It increases by 1 at a time, and the number of valence electrons also increases. And also I have told you that as you start with the next element of the next period, then the period shells also start increasing. Let us again come back to our topic. Now, the number of electrons which can be accommodated in any of the shells, it is determined by using the formula 2n square, where n is your shell number and your electron capacity is deduced by substituting the shell number. So the formula is 2n square. So for the first shell, that is the K shell, this is your first shell, so n is 1. So in place of n, when you substitute 1, so 2 multiplied by 1 multiplied by 1 comes out to 2. Similarly is the case of L shell. The shell number is 2. So if you substitute 2 in place of n, 2 multiplied by 2 multiplied by 2, 8. For M and N shells, it is 18 and 32. So the maximum capacity of electrons which can be accommodated in any of the shell, it depends on this formula. And the maximum capacity of K shell is 2 electrons, L shell is 8 electrons, M shell it is 18 and N shell it is 32 electrons. Now the last topic I don't want to discuss more because we have already seen all the use your brain powers and all for atomic size. Just we will go to the first periodic trend, that is valency. So valency of an element, it is determined by the number of electrons present in the outermost shell. From the 9th standard I have told you what is valency. In short, valency is the combining capacity of any element. Now look here with the case of sodium. Atomic number is 11. Electronic configuration is 281. One electron is there in the outermost shell. This sodium will donate, so it becomes stable with the configuration of 2 and 8. So valency is 1. Magnesium 282. Valence electrons are 2. So valency is 2. Aluminium valence electrons 3. Valency is 3. Oxygen you can see 2, 6. Now valence electrons are 6, but will 6 electrons be donated from oxygen? No. What will oxygen do if 2 electrons are received? Here it will be 6 plus 2, 8. So second shell, you know the maximum capacity is 8 electrons. So instead of donating 6, oxygen will accept 2 electrons and hence valency is 2. You can take an example of a 0 group element or a noble gas, neon, having atomic number 10. So 2, 8 is the electronic configuration. It is already satisfied with 8 electrons in the second shell. So it will neither donate nor it will accept any electrons and hence valency is 0. So from this we can say that all the elements belonging to the same group, they have the same valency. Now we come to our next topic, atomic size. I have told you that the size of an atom, it is indicated by its atomic radius. And what is atomic radius? It is the distance between the nucleus, that is the center of the atom, and its outermost shell. So in short you can say about it can be like a radius. So atomic radius of the circle, when you draw any circle, then radius has to be taken into account. So that atomic radius is expressed in the unit picometer, pm, which is smaller than nanometer. So 1 picometer is equal to 10 raised to minus 12 meter. And I have told you that while going from left to right within a period, the atomic number, it increases 1 by 1, and the additional electron, it gets added to the same outermost shell, and hence the atomic radius, it goes on decreasing while going from left to right within a period. But for a group, the atomic size, it goes on increasing when you come from top to bottom, because a new shell gets added every time, and therefore the distance between the outermost electron and the nucleus, it also goes on increasing and the atomic size increases. Same is if you see the topic of metallic non-metallic character, you have to see that while going from left to right within a period, the outermost shell, it remains the same, but the positive charge on the nucleus, it goes on increasing while the atomic radius goes on decreasing. So depending on it, we can say that while going downwards in any group, the electropositivity of elements, it goes on increasing, electronegativity goes on decreasing. While you go from left to right, electronegativity goes on increasing, electropositivity goes on decreasing. And with this, we complete with the discussion, the revision of chapter number 2. This is a chapter which is mainly based on theoretical concepts. Up till Mendels periodic table, up to the structure of the long form of periodic table, you have to study, learn it by heart. whether it is Robert's law of triads, whether it is Newland's law of octaves, whether it is your Mendels merits, demerits. But later on, when you start with the periodic trends, or when you start with your groups, periods, and electronic configuration, concepts should be known by you. Based on the concepts, question will be asked. You have to apply the concept, apply your own logic, and get the answers. So on Thursday, I will be taking up your Maths 1 period for the revision of chapter number 3, Chemical Reactions and Equations. So be prepared, read the chapter at least once before you attend your next session. And once again, I tell you the portion for your second online assessment. You have already received it in your groups. The portion is chapter number 1, 2, 3, 6 and 10. Thank you from my side for today. Keep studying, keep completing your notebooks, and the most important thing is keep reading. Thank you, dear children.